All right, today we're covering 3.2, parallel lines and transversals. All right. What makes two lines parallel with each other? They're never going to touch, right? Never intersect. Okay. So they're always going to be that same distance apart from each other. All right, and then what is a transversal? Go ahead.
Transversal, when you have two parallel lines, it goes through both of these parallel lines. It makes like two sides.
Okay, so a transversal is one that goes through two other lines and intersects them at two different points, right? So in our little example here, the transversal is what letter? What line? Line what?
T.
T. Okay, it's the one that's going through the other two. All right, very good. So these theorems only work if your two lines that are, that the transversal is going through are parallel with each other. And remember these little arrows there that I'm pointing at show that they're parallel. All right, so let's look at this. So we've looked at how to identify, like, okay, these two angles are corresponding or alternate interior or whatever. But now we need to be able to figure out, like, how to find the missing angles, knowing that those are, corresponding or alternate interiors. So when they're a transversal is going through two parallel lines, your corresponding angles are always congruent. So put big old congruent symbol there. They're going to be congruent with each other. And congruent just means what?
Same.
The same, or like, in a sense, like they equal the same amount, right? Okay. Alternate interior theorems will always be congruent with one another. Alternate exterior will always be congruent. Consecutive interior is the only one that's different out of these four, and it says that they are supplementary. What does it mean if they're supplementary?
Equal 180.
They add up to equal 180. So we're going to say they're equal 180 degrees. Okay. Now I want to add a couple of our older ones at the bottom. Remember vertical angles? Vertical angles form a what with each other?
X.
An X. And vertical angles are always going to be congruent with each other. Okay? That's not one of our theorems here, but it's just something you need to know. And then the last one is linear pair. A linear pair of angles form a what together?
Line.
A line. And a straight line equals how much?
180.
180. So a linear pair is always just going to equal 180 degrees. Okay. So basically you got 6 angle pairs there. 4 of them just are going to be congruent. And then 2 of them are going to add up to equal 180. All right. So it's pretty simple to remember those two things, as long as you remember which ones are which. So basically the way we do it is we'll look at 2 angles. If they say you look at 2 angles and you're like, oh, those are alternate exterior angles, then you'll look here and you'll say, oh, our theorem says alternate exterior angles are congruent. So if one was 50, the other one would be 50, the one you're looking for. Okay? Does that make sense? So you identify what angle pair it is, and then you just figure out, like, are they congruent or equal 180 with each other? All right, that being said, let's do example 1. It says, find the measure of angle 1 and angle 2 and tell which theorem you use in each case. Okay. So I know I've got to find measure of angle 1. And I've got to find the measure of angle 2. So we always want to start with the angle that we know right now. Which one do we know? The 110 degree one, right? So it doesn't matter what order I find the angles in, just because angle, we don't have to find on angle 1 then angle 2. Because sometimes you're going to find that you need to find what angle 2 is so that you can help you to find angle 1. Does that make sense? But right now, angle 1 and 110 are special, or they have a special angle. What are those special angles? Like, out of those 6 that are on that front, which one is that one? Like, are they corresponding? Are they alternate interior? Are they alternate exterior? Are they consecutive interior? Are they vertical or linear? No, the 1 and 110. They're alternate interior, right? They're both inside the 2 lines, and they're on different sides of transversal, so these are alternate interior. Now, what did we say on the front that alternate interior angles are with each other? Are they congruent or equal 180? They're congruent. Okay. So if they're congruent, how much is angle 1 equal? 110. And then you'll put what theorem? And it's the alternate interior theorem. I don't mind if you shorten the words a little bit, as long as it's really easy to see what they are. Okay, but you have to put the word theorem on here. Have to have theorem. All right, angle 2. There's a couple different ways we could find what angle 2 is. But compare the angle 2 with the 110. What angle pair are those 2? If they are one of the 6. Are those one of the 6 ones we have? Yes, these are corresponding. Remember, if you drew that box around them, angle 2 and the 110 are in the same position, right? So that makes them corresponding. So corresponding angles are what with each other? The same. They're congruent, right? So angle 2 equals how much? 110. And what theorem? The corresponding theorem. Now, there was another way I could have done this. And I'm just going to put the other way of doing it. Just, you don't have to put 2 on these, but just so you know, like, there are different ways. If I was to compare angle 2 to angle 1, what kind of angles do those make with each other?
Vertical.
They're vertical angles, right? They form an X. And vertical angles are congruent. So if I knew once I found what angle 1 is, angle 1 and angle 2 are vertical angles, and I could say, oh, angle 2 is the same thing as well. So I could have said, or vertical angles. And that's it. All right, so number 6 from the worksheet you're doing today. What did y'all get for angle 1? How much? 140 degrees. Not corresponding. When I look at 140 and the 1, what kind of angles are those? Alternate interior. They're on different sides of the transversal, the 1 and the 140. So this is alternate interior theorem. Measure of angle 2 then, so we got 140 for angle 1. What did you get for angle 2? 40. And I heard linear pair. So the 140 and the 2 form a straight line together, right? So those are a linear pair. They add together to equal 180. What's another way you could have said? 40 degrees, and what's the other theorem you could have used? Consecutive interior. Angle 1 and angle 2 are consecutive with each other, right? And we know consecutive adds up to 180. So you could have said linear pair or consecutive, interior theorem. All right, very good. All right, example 5 in the notes. Find the value of x, show your steps. Yay, we've got algebra mixed in. Everybody loves adding algebra into the geometry, right? Okay. So it's not going away. It's going to keep going all year long. So, but we're going to start out by doing the same thing. We need to figure out what angle pair we got, or we have. So when I look at the 110 degrees and the x plus 12, do they fit one of the angle pairs that we know? Okay, good. So I heard it. These two are alternate exterior. In class, alternate exterior angles are what with each other? Congruent or equal 180? Congruent. So if they're congruent, all I'm going to do is say x plus 12 equals 110 because they're congruent. All right, so x plus 12 equals 110. Now I just need to solve for x. So I'm going to subtract the 12. And what does x equal? 98. Is that it, or do I need to plug it in? What's the instruction say?
Find the value of x and show me steps.
Find the value of x. Did I find x?
Yeah, you already did this.
Yeah, so do I need to plug it back in?
No.
No. And then what was the theorem we used for this? Alternate exterior theorem. Okay. And that's it. All right, number 7. So we got to find the x and the 4x. And we're going to compare it with that 52 degree that we know. Does that fit one of our 6 angle pairs, the 4x and the 52? If it does, which one? I know, but 4x and the 52, like which one? Is it are they corresponding, alternate exterior, what? Okay, so I heard 2 people say corresponding. So if I put the box around it to check, is a 4x and the 52 degrees in the same corner of the box?
No.
No, so they can't be corresponding. They're not in the same position.
Alternate exterior.
Okay, so he says alternate exterior. Oh, both of these exterior angles, are they both outside the lines? 2 lines? Yeah, because our interior would be in here, right? So they are both exterior. Now my transversal going through, are those on different side of the transversal? No, so they can't be alternate exterior.
So they're consecutive.
Do we have consecutive exterior?
No.
No.
So they're corresponding.
No, we already proved they're not corresponding. So do they fit any of it?
Here. I don't know.
No. They're not linear either because they're not right next to each other. They're not adjacent. Okay. So do they fit any of our 6 we have?
No.
No. Okay.
I know they both.
No, we just have to do an extra step. Good try. Okay. So the deal is that they're not any of our special ones. But what about this angle 6 and this 52? Are those one of our special pairs? What are those? Corresponding. Those are in the same position, right? So our first step is we're going to find what angle 6 is using the corresponding theorem. All right, and the corresponding theorem tells us that these are what? Congruent or equal 180? Congruent. So angle 6 equals how much? 52. So step 1, measure of angle 6 is equal to 52 degrees because of the corresponding theorem. I'm putting here angle 6 is equal to 52 degrees. Now my second step, I want to compare that 4x with angle 6. Now this one is one of our 6 special angles, but which one? 4x and angle 6. Which one of our special angles is it? Which one of the 6? All right, let's go through them then. Are they corresponding? Are they on different intersections but the same position?
No.
No. Are they alternate interior? Are they both inside?
No.
No. Are they alternate exterior? Are they both outside?
No.
No.
Linear.
Are they, where it said they're not interior, are they vertical? Do they form an X?
Linear.
No. Are they linear? Are they right next to each other and make a straight line?
Yes.
Yes. This is a linear pair. And linear pair does what? Are they congruent or equal 180? They equal 180. All right, so since they equal 180, I can take that 4x. And does somebody know what we're going to do with it? 4x, then what?
You're gonna move it.
Divide by 4.
4x plus 52.
I mean, right now, what did you say?
4x plus 52.
So he says we're going to add 52,
Oh, the either way.
and then they're going to equal how much? 180. Because the linear pair adds together to equal 180. So basically, remember, 180. If they're a linear pair, I'm saying 4x plus this 52 add together to equal that straight line, right? They add their total. So we have to say 4x plus this equals the 180. Okay. Now we just solve for x. Subtract 52. 4x is equal to, what's 180 minus 52?
148.
128. And then divide by 4. And what does x equal?
7. No.
How many times 4 going to 12?
33.
3. Then how many times 4 going to 8?
2.
32. That's our answer. So this is number 11 on your worksheet today. And how many angles do we need to find?
3.
3. Okay. So I'm going to help you find an angle, measure of angle 1, and then I'll let you find the other one, other 2. In a couple, 3 minutes. So we got to do this quick. Okay. All right. So let's find angle 1 first. Remember I told you can cover up the other 2 angles you're not using right now, or intersections, and just focus on the 2 intersections we care about. So angle 1 in the 80 degrees. What kind of angles are those? They're what? Consecutive interior. Good. And when we look on the front of our foldable, consecutive interior does what? Congruent or equals 180? Sure? They equal 180. So I know that angle 1 plus 80 equals 180. So what do I do to figure out what angle 1 does then? It does equal. If I know that this one plus this one equals 180, so we're going to do 180 minus the 80. Gives me 100. So angle 1 is equal to 100 degrees. And what theorem did we use? Consecutive interior. Okay. Then literally when you're doing like angle 2 and 3, like angle 2, you just turn this and we do use 1 and 2. Now that we know that 1 is 100 degrees, I can say, okay, angle 1 and 2 are consecutive interior as well, right? Then we can find it, and then you can keep turning it and figure it out. All right, but I'll let y'all find angle 2 and 3.